All right. So hi, everyone. Welcome to Well-Architected and Secure Kubernetes Manifests with cdk8s. My name is Eli Polonsky. I'm a senior software development engineer at AWS. I'm also leading the CDK for Kubernetes, or cdk8s project. All right, so let's get started and see what we have on the agenda for today. So first, we're going to start with the problem statement. What are we actually trying to address? What are we trying to solve? We're going to do a quick introduction to cdk8s, if you're not familiar with it, and its approach to Kubernetes manifest authoring. We're then going to dive deeper into cdk8s Plus, which is a library built on top of cdk8s to help you simplify configuration, resource configuration for Kubernetes. And we'll see all of this in action with a demo, and then switch to talk about policy as code and how to protect your manifests from misconfigurations and how cdk8s can help you do that. Again, followed by a short demo, and then we'll finally wrap things up with a few useful resources for you to follow up. So what are we trying to solve here? I think the statement here is that authoring production-grade Kubernetes manifests is a complex task. And I realize that complex is relative, right? It depends on your role and it depends on your experience. So to be more accurate, let's just say that it's more complex than it can be, right? And I also realize that I can't really argue complexity without offering an alternative. So what we're going to see in this session is basically an alternative to Kubernetes manifest authoring using cdk8s and cdk8s Plus. So throughout this session, we're going to use this example application. Pretty straightforward. We have a web application that accepts incoming traffic from the users. We have a DB to store our data, and we have a read-through, write-through cache kind of in between to have latency and performance enhancements. Okay, so now let's also define our production requirements, right? So this is just the functional description of the application, but we're talking here about authoring production-grade manifests. So let's define what our production requirements are. So the first thing is that everything needs to be highly available, right? We need to have at least 2 instances of every single part of our application. So we're going to have 2 instances of the web, of the cache, and of the DB. But actually, this isn't really highly available, is it? Because what happens if 2 pods or 2 instances are deployed on the same node? If that node crashes, then you're going to have an outage. So what we really need is for them to be deployed on separate nodes. The next requirement is that the web and the cache actually need to be co-located with each other, because the web's going to access the cache pretty frequently. It's a high read application. So we need the web and the cache to be deployed on the same node. The next thing is that we want to restrict the communication or the network communication between parts of our application. We know exactly what the network should flow, right? The web should flow to the cache, and the cache should flow to the DB, and nothing else. No one should connect to the web. No one should connect to the cache except for the web application. And the final thing is, we also want to grant a specific user or a specific group permissions to manage this application entirely. In this case, let's say we have a front office group, and we want that group to manage this application. So how would you go about writing a manifest like this? The application part or the functional part is pretty simple. You write a few container images, you push them to ECR or whatever, and you're done. But all of these production requirements complicate this fairly simple application. And again, depending on who you are, depending on your experience, you might have extensive Kubernetes experience, or you might have just written this type of application last week. But if not, and in many cases, you're going to find yourself here, basically sifting through a lot of Kubernetes docs. If you're lucky, you're going to, this will be enough. But if you're not lucky, you're going to find yourself in the edges of the internet with looking for blogs and guides on how to actually configure all of these properties and all of these functionalities. And eventually, you're going to end up here. And this is the Kubernetes manifest that implements this fairly simple application. It contains 430 lines of code. It has 22 resources, and it has way above 50 distinct configuration properties. So the question is, can we do better than this? And this is where cdk8s comes in. cdk8s is a software development framework that allows you to author Kubernetes manifests using general purpose programming languages. So you interact with classes, or as we call constructs, that represent the Kubernetes resources. So for every resource, you're going to have a class or a construct that you can configure it using the exact same properties that you would in the YAML file. cdk8s is actually built on top of JSII and constructs, which is the underlying technology of the AWS CDK. If you're familiar with it, we kind of extracted a lot of the core technologies from the AWS CDK and implemented it on the Kubernetes domain. So in this example, we're instantiating a Kubernetes deployment. There's a kube deployment class there, and we're providing every single property that we would in the YAML. But since this is now code, you can leverage control flow and variables and conditions and reduce your complexity of the manifest. One thing to note about cdk8s. So cdk8s is not tied in any way to AWS or to EKS, which is kind of weird to say at an AWS Container Day, but it's not tied to any AWS service. It's actually a CNCF project in Sandbox right now, but we are working towards incubation and so forth. So don't worry about using cdk8s in other environments. It can run on any Kubernetes cluster, and it produces pure Kubernetes manifests. So this is the cdk8s workflow in a nutshell. You start with installing the cdk8 CLI. It's an NPM package. Then you initialize a project. You can choose from a variety of languages. We have support for Java, TypeScript, JavaScript, Python, Go. We're adding more and more languages as we go. So you initialize your project, and you start writing your source code, like we saw before. This is basically your charts and your constructs. You then run cdk8s synth, which translates or serializes that source code into Kubernetes manifests. And at that point, cdk8s is kind of done. Now you have Kubernetes manifests that you can deploy to your cluster, whether it's kubectl, GitOps, whatever deployment mechanism you prefer. cdk8s is not a deployment tool right now. So just integrate that in your normal deployment of Kubernetes manifests. And then finally, because this is all code, you can package it and publish it to standard package managers, Maven, NPM registries, and all of that, and then share it with your other teammates or with the world, with the community. All right. But cdk8s alone doesn't really simplify the authoring of Kubernetes manifests. Like we saw, you still need to provide every single property that you would in the YAML file. It just gives you a better mechanism or a more robust mechanism because you're using code. And there's a famous quote that I like. I'm sure you're familiar with it. It says, "Perfection is achieved not when there is nothing more to add, but when there is nothing left to take away." And this is, nothing is ever perfect, especially in software. But I think this is a very nice guiding principle to any simplification process. And this is what we're talking about right now. We're talking about how to simplify Kubernetes manifest authoring. And this is where cdk8s Plus comes in. So the crux of why Kubernetes manifests are complex is because they don't declare intent, right? They declare desired state. And those two are not the same. It's actually true for all orchestration platforms. You declare your desired state because that's easy for a machine to parse and understand. But for humans, when we usually interact with each other using intent, that's not the same. We want to interact on a higher level, and it doesn't have to be that the manifest that humans interact with is the same manifest that you have to send to the Kubernetes engine for it to interpret. Right? We've seen this with other technologies. When you're writing C programs, the program itself is meant to be interacted by humans while it compiles down to assembly, and then that's what you eventually send to the machine. So It's kind of the same thing with Kubernetes manifests and with cdk8s+. So let's take a look at this example from before and apply the simplification process that we saw to this resource. So let's start with this metadata configuration. So you'll notice that on the screen, I'm kind of crossing out a lot of stuff as we go along, just to simplify the configuration. So this metadata name property is not really required, or does not really convey our intent, right? It's just Kubernetes requires us to name all of our resources, so we have to give a name for every single resource, but it's not inherent in our application intent. So let's just get rid of it. Let's say we don't need it. The next thing is the spec and the template labels and all of that. Again, this is not part of what we want. It's part of what Kubernetes needs. Kubernetes needs to know how that deployment selects its pod, and it uses that with the label selection mechanism. So let's get rid of that as well. The name of the container, same thing. We don't normally name our containers. We don't have to name our containers when we just deploy it locally. So let's get rid of that as well. And those selectors at the end also are not really important to us. So we can see that eventually, when we kind of strip down all the implementation detail and all the desired state that doesn't convey intent, we're left with a single line of code that just says, hey, Kubernetes, please deploy this container image. And so on the left, you see the state, which is the cdk8s core kind of library or the Kubernetes manifests. And on the right, you see the intent-based APIs, which are cdk8s+. And you'll see this API come up a lot during this session. And I'm also happy to announce that cdk8s+ just recently got its first major version, actually yesterday, and an official announcement is coming up later today. All right, let's look at all of this with a demo. Hopefully this works. Yep. Okay. All right. Okay. See, I'm a little bit out of time, but so I'm going to do this a little quicker than I originally planned, but hopefully you'll be able to follow up. Okay, so this is an empty cdk8s application. I used cdk8s init to initialize it. Again, I'm using TypeScript, but you can use a lot of different languages as well. And so what we're going to be doing is just implementing this application and all of its production requirements just now. And hopefully, we don't have to go to AWS blogs or Kubernetes blogs or documentation. We'll just let the library kind of guide us as we normally do when we're writing application code. All right, so the first thing I'm going to do is import this cdk8s+ library. And here we go. cdk8s+. Cool. And now I'm going to start defining my resources. So again, the idea here is so that not just Kubernetes experts can write these types of applications, right? I'm a developer. This might be my first Kubernetes experience. I kind of look at, I know what cdk8s is. I've looked at its concepts and its documentation. I just want to start writing this application. And I know the basics of Kubernetes. I know what a deployment is. I know what a stateful set is, but I don't know all the nitty-gritty implementation details of how to configure all of those requirements that we spoke of. So let's just go ahead and start. I have a DB, and I know that DBs are usually implemented with stateful sets. So I'm going to create a stateful set, and you can already see kind of the nice value of cdk8s, right? This is auto-completion by the IDE. I didn't configure anything to do this. This is just the built-in support for TypeScript that Visual Studio Code has. And you see all of this inline documentation, and everything is type safe. So let's just go ahead and configure this. So I'm going to create a stateful set, and I'm going to give it an ID. And this is where our simplified API comes in, right? All I need to do is tell the stateful set what is the container image that's running my DB. So for the sake of the demo, let's just assume that I have this DB image, and that the application itself is running on port 8000. Right. Okay, that's basically it. Now I have a stateful set running this DB application. Next thing I want to do is configure my cache. So the cache is going to be just a simple deployment, and I'm going to have to access it, so I'm probably going to have to expose it with a service or something, but let's see how we do that. So I'm going to create the cache, and this is going to be a deployment, cache, and I'm going to do the same trick here with the containers, right? Except this time, I need to tell the cache how to connect to the DB. It's a read-through, write-through cache, so it needs to connect to the DB. And the way to do that is by using environment variables. So I'm going to pass in a few environment variables here. I'm going to say DB host. So there's a few kind of API quirks here, and value from value. So what is the DB host? What's the address of the DB? So the address of the DB is the service that serves the stateful set. But wait, we didn't actually configure a service for the stateful set, and every stateful set needs a service behind it. So what cdk8s does actually is it understands, right? It understands that you need a stateful set, which means you need a service. And if you didn't pass in a service explicitly in the configuration of the stateful set using the service property, then it will go ahead and create a headless service for you and wire up all the selectors that are needed to do that. And then you can access this service using db.service.name, and we're going to do the same thing with the port. And this is going to be port. Okay, cool. And now we're going to do the same thing for the web app, right? And it's going to be, again, it's going to be a deployment. So this is going to be web. We're going to give it an ID, web. And this time the web needs to access the cache, so I'm going to do the same trick. This is going to be cache, right? But now I don't have a cache service yet. So cdk8s doesn't create a service implicitly for me when I use deployments, like it does for stateful sets, because they're not required. So I can create this caching service here just by using the cache API. So this is going to be cache service, cache, expose via service. So this expose via service command or method is very similar to the kubectl expose command. If you're familiar with it, it just creates a service for this deployment, and then I'm going to use this cache service here, and we're done. Right? And now I need to expose the web deployment because that's what Sorry? Oh yeah. You're right. Thank you. So this is going to be cache. This is going to be web. Thanks. Okay, so now I'm going to need to expose this web deployment as well. And again, I'm going to do web.expose via service. But this time I'm going to use a service type of load balancer because I needed to accept incoming traffic from outside the cluster. Right? I could have also used expose via ingress, but this is kind of a simple way to do this. Okay, so this is my skeleton app, right? This is just the functional parts of the application. We still haven't done all the production requirements. So let's go ahead and do that. Let me just check my time real quick. All right. So the first production requirement we had was highly available, right? So we're going to go to all of our components, and we're going to say, let's have 2 replicas. So that's fine, but we also need to spread those replicas across different nodes and across different availability zones like we saw in the previous section. This is exactly the requirement from highly available. And so cdk8s has a nice property for you that says spread. And then you can just configure spread equals true, and it will know how to do that. It will know how to configure all the affinity rules, the node affinity, and all of that stuff, so that and the pod affinity, so that those replicas are deployed on 2 different nodes. So we're going to go ahead and put that configuration everywhere. And here. All right, cool. So now we have a highly available application. All of our resources are highly available. And the next requirement that we had was for the web and the cache to be co-located with each other, right? So this is my intent. I want them to be co-located. I don't have the slightest idea of how to configure that using Kubernetes properties. So let's see what kind of API cdk8s+ has to do that. So if I go to the web deployment here, there's a scheduling property that basically exposes a bunch of scheduling features of Kubernetes. Things like co-location, separation, toleration, all that stuff you can see very explicitly here using intent-based and semantic APIs that really convey what you need. And you have inline documentation for all of it. So let's select the co-locate. And basically all I need to do is just pass in the cache deployment. That's it. All of the information that cdk8s+ needs is stored in those objects, in those instances, all of the selectors and the labels that it auto-generates. So it knows exactly how to configure it, and we'll see it a little bit later. Okay, so we have co-location ready. Now we need the network's restrictions, right? We don't want the network to flow in the directions that are not expected. So the way to do this is, by default, when you create a Kubernetes pod, it is actually open for all egress and all ingress communication, right? So first off, we don't want that. We want all of our pods to be isolated for any communication, and then we can explicitly configure whatever we need. So again, there's a nice property for that called isolate. And I'm going to set that to true to every single resource. And now we need to explicitly allow the network direction that we want. So we want the web to connect to the cache. So we use the allow to, and we pass in the cache. And we want the cache to connect to the DB, right? That's it. And that basically guarantees that all of these connections are allowed. Okay, what else do we have from the production requirements? I think we're pretty much ready, except for the whole granting permissions to the Kubernetes group. So we have a front office group that the Kubernetes operator created for us, and this is how you reference it in cdk8s. So we're going to reference it like this. So its name is front office. And you guessed it, there's a permissions API on every single part of our application. And if we go to that, you can see that there are grant methods here, which are similar to the grant methods from the AWS CDK, if you're familiar with it. So we're just going to go ahead and grant read write to this front office group. And we're going to do the same thing for the cache and the same thing for the DB. And that's it. All right, so now let's go ahead and synthesize this application. So we're going to run cdk8s synth. And we have this massive Kubernetes manifest that we spoke of before. This one actually is 461 lines of code, has all the necessary resources, all the roles, the role bindings, the network policies, the node affinity, pod anti-affinity, pod affinity configuration, all of that is in here. You can count on it. And this is the manifest that you go ahead and deploy to your Kubernetes cluster. Again, pure Kubernetes, has nothing to do with EKS or AWS. All right, cool. So that was this part of the demo. Let's go back to the slides. All right, so just one note about this. cdk8s+ is not what we call a mental model abstraction. It doesn't, you still operate with the core Kubernetes resources, right? You're not operating at a higher level. It's just that it's a little bit easier to configure all those Kubernetes resources, but you're still operating with deployments and stateful sets and all of that. So it's not like abstracting away all of those things. You can do that. You can do the abstractions. We call them L3 abstractions, and hopefully cdk8s+ allows you to do that simpler, and you can do those abstractions and share them with your teammates But this is not what cdk8s Plus is about. cdk8s Plus is just about simplifying the core Kubernetes resource configuration. Okay, so no matter what tool you use, whether it's cdk8s or you're just authoring pure Kubernetes manifests, you're gonna end up with mistakes. There's no avoiding that. cdk8s Plus doesn't enforce. It lets you do whatever you want, and eventually you're gonna end up with mistakes. And we can see that, from the Kubernetes, from a recent study by Red Hat, we can see that 95% of, human errors were the major contributing factor in 95% of breaches. So we still need another layer of protection to our manifests that's not just using semantic APIs. And this is where our integration with validation tools comes in. So we just recently added a validation mechanism that lets you plug in third-party validation tools such as the tree, SNCC, Chekhov. So you can write plugins for all of those tools and hook that up into your cdk8s process. And what will happen is that when cdk8s synthesizes your manifests, it will pass those manifests on to that tool for the validation. And if that tool reports an error, if that tool has detected some misconfigurations, your synthesis process will fail, which means your CI process will fail, your local workflow will fail, and you're not going to be able to push those manifests to the cluster. And quick demo, final one. Okay. So what we've done to design this feature is we've partnered with a company called The Tree. They're a company that they're an AWS partner, and they're specialized in detecting those misconfigurations in your manifests. And let's have a look at how this works. So we're gonna go to their documentation. This is all on GitHub, all open source. And so they basically say you need to add this validations snippet to your cdk8s configuration file and just run synth. So let's go ahead and do that. And let's run synth again. So I didn't change any code. I just added a snippet to my configuration file. And you can see that it's synthesized the manifest, and now it's performing the validation. And we have some errors. Let me just increase this. All right, so you can see it found one violation. It says, ensure each container image has a pinned tag version. So what does that mean? You can also see in the report, like, what is the construct path, what is the resource that's violating, which manifest is violating it, and even suggestions for fixes using the tree knowledge base. So I know what this error means. It means that I shouldn't be assuming latest here, right? It's not good practice to assume latest. It makes for undeterministic deployments. It can also be a security incident. So let's just go ahead and put a tag on all of these images. And if we run synth again, all right, you can see now that the validation ended successfully, and our exit code is 0, and everything is fine, right? Now you can pass that manifest to your cluster, and it should be good. And you can also configure validations here using a remote file. So we know that a lot of companies have central compliance teams that actually define all of these policies, and they're not the same people that are writing the manifest. So you can have a separate remote file for the people writing the policies, and just have your developers consume those policies every time they synthesize the application, every time they write cdk8s code. Okay, that is it. And we have one last slide. So just a few useful resources: the cdk8s website, specifically cdk8s Plus documentation. We spruced it up quite a bit. There's a lot of use cases here, a lot of stuff kind of inspired from the Kubernetes doc, but simplified and made more intent-based. The manifest validation mechanism also is on the website. Check out the tree plugin. Again, it's all open source. They're a really cool tool for detecting those types of misconfigurations. And you can also write your own plugins, whether it's internal or you want to write a plugin for an open source tool, you can also do that. And of course, all of the code that I mentioned here is available on GitHub, on our repository. And thank you. That was a lot to get to in 30 minutes. I'm going to be here till Friday, mostly at the AWS booth, and come chat.